Welcome to the DIY Honda Garage channel. The DTC P0A94 indicates a performance problem with the DC-DC converter in the 2022 Honda Civic. This diagnostic trouble code signals that the powertrain control module, PCM, has detected an abnormality regarding the DC-DC converter, which is responsible for converting direct current from the high-voltage battery to a lower voltage suitable for the vehicle's electrical systems. Located within the vehicle's power electronics module, the DC-DC converter plays a critical role in maintaining the power supply for auxiliary devices and charging the 12-volt battery. When the PCM registers a failure or abnormal input from this component, it records the DTC, which aids technicians in pinpointing the issue during troubleshooting. Understanding the functionality of the DC-DC converter and the systems connected to it is crucial for diagnosing the P0A94 code effectively. The DC-DC converter's primary role involves converting the high-voltage direct current from the vehicle's hybrid battery system into a usable low-voltage direct current for the car's electrical systems. It's an essential component that supplies power to various electronics, including lights, infotainment systems, and control modules. The DC-DC converter is usually located in the power electronics module of the Honda Civic, making it somewhat accessible during repair or replacement tasks. When the PCM receives input indicating that the converter is underperforming or has failed, it logs the DTC P0A94, which can lead to symptoms such as electrical malfunctions or failure to start in extreme cases. Understanding its exact location and role helps in isolating faults more effectively. Several potential causes can lead to the P0A94 error code being triggered. One possibility is an internal failure within the DC-DC converter itself, which could impact its ability to function correctly. Additionally, shorted or damaged wiring within the circuit can also lead to erroneous signals being sent to the PCM. Another reason might revolve around issues with the ground circuit, affecting the converter's performance and efficiency. Lastly, it's crucial to consider the PCM as a source of the problem. If the module is not interpreting inputs correctly or has developed its malfunction, it can also trigger the DTC. Thorough inspections addressing these components are essential for accurate diagnosis. When the DTC P0A94 is logged, several symptoms may manifest that indicate a problem with the DC-DC converter. Drivers might notice warning lights illuminating on the dashboard, particularly those relating to electrical systems or performance issues. Additionally, various electrical issues might arise, such as dim lights or failure of electronic accessories to operate. In more severe cases, the vehicle may not start, indicating a significant failure in converting power from the main battery. It's vital for technicians and owners alike to keep an eye out for these symptoms, as they can point toward the need for immediate troubleshooting and repair of the DC-DC converter or associated wiring. The first step in troubleshooting the P0A94 code involves performing a test drive under conditions that activate the auto idle stop system. This requires driving the vehicle until the system is engaged, which helps in determining if the DC-DC converter operates as expected when the engine is automatically stopped. Observing vehicle behavior under these circumstances provides the technician with crucial initial insights. After stopping the engine, if any triggering conditions or failure signals occur again, it should indicate that there is indeed an issue with the DC-DC converter or its associated systems. This first step sets the groundwork for subsequent inspections and should be executed meticulously. In the second troubleshooting step, technicians will focus on inspecting the DC-STS signal, which is vital for conveying the status of the DC-DC converter to the PCM. It's crucial to verify whether this signal is shorted to ground, as any grounding issues can disrupt the signal flow and contribute to performance problems. This inspection may include testing wiring continuity and ensuring that no components are shorting out. If any abnormalities are discovered in this step, they need to be addressed immediately, as they could be the root cause troubling the converter's operations. Ensuring the integrity of the DC-STS signal is a key part of the troubleshooting protocol. The third step involves a detailed wiring inspection for the DC-DC converter, particularly focusing on the power supply lines +B DC-DC1 and +B DC-DC2. It is vital to confirm that these circuits are delivering adequate voltage and not suffering from interruptions. Checking the ground circuits is equally important, as poor grounding can cause performance issues within the DC-DC converter system, leading to abnormalities in operation. Any detected problems in these circuits must be rectified immediately, as they could account for the poor performance experienced and contribute to the P0A94 issue. This phase of troubleshooting is essential for confirming that the DC-DC converter receives proper power and ground, ensuring effective diagnosis. In this step, technicians must examine the output from the DC-DC converter to validate that it operates effectively. It's essential to check if any aftermarket parts are connected to the DC-DC Out 1 and DC-DC Out 2 circuits, as they may cause irregularities. This inspection should be paired with confirming any error codes recorded in the HDS, especially the DC-DC converter output error codes. If any errors are noted, they warrant immediate attention, as they can severely impact the performance of the vehicle. A successful inspection phase will determine whether the DC-DC converter output is functioning correctly or if further procedures are necessary. The fifth step requires evaluating the internal circuit of the DC-DC converter, focusing on the parameters recorded by the HDS system. Technicians must confirm the readings of the various parameters, including the DC-DC converter's CST error and input-output error codes. It is essential to determine whether these readings are within normal conditions. If any abnormalities are detected, this could indicate an issue with the DC-DC converter or related components. This step meticulously diagnoses the internal workings of the converter, providing a pathway for pinpointing faults that may not be readily apparent in the output evaluations. Following through will clarify whether the internal circuitry is leading to the recorded DTC. This step involves the direct replacement of the DC-DC converter if the previous inspections confirm faulty performance. By installing a known good unit, technicians can attempt to reproduce the failure conditions that triggered the DTC P0A94. This method allows for verification of whether the new unit resolves the issue and normalizes the vehicle's performance. If the failure reoccurs, this would illustrate that other components upstream are also likely contributing to the failure. On the other hand, if replacing the converter resolves the symptoms, it confirms that the original unit was indeed defective. This replacement phase is critical for ensuring the vehicle regains its intended capabilities. The final step involves inspecting the PCM itself, especially if all other inspection items have indicated normal conditions. If the previous checks signaled that all components are functioning correctly, yet the DTC P0A94 persists, the PCM could be at fault. Checking for logical abnormalities within the module will help ensure it processes inputs correctly. If defects within the PCM are confirmed, replacing or reprogramming the module may be required. This step is vital, as it scrutinizes potential issues that may not be readily accessible through initial inspections. Addressing the PCM comprehensively can finally resolve the troubles tied to the DTC P0A94. After completing all troubleshooting steps related to DTC P0A94, it's essential to verify that all repairs were successful. Technicians should recheck all the components previously inspected to ensure no residual faults remain. Following this, it's important to clear the DTC and retest the vehicle to ensure that the error does not reappear. During this monitoring phase, technicians should pay attention to any recurrence of warning lights or electrical dysfunctions. Ensuring that the DTC doesn't resurface after repairs constitutes a crucial part of the verification process and solidifies the reliability of the repair work done. To avoid encountering the P0A94 code in the future, implementing preventive maintenance is vital. Regular system checks can assist in identifying potential issues before they escalate into performance problems. Technicians should examine all electrical connections associated with the DC-DC converter periodically, ensuring there is no corrosion or wear that could jeopardize functionality. The use of high-quality components during any replacements is another important preventive measure that can directly affect the longevity and performance of the vehicle. Staying proactive with maintenance practices ensures the DC-DC converter and related systems operate optimally, reducing the risk of failures and DTCs in the long run. In conclusion, understanding DTC P0A94 is essential for ensuring effective repair and maintenance of the Honda Civic 2022 Plus. Familiarity with the diagnostic processes allows technicians to identify the roles of critical components like the DC-DC converter and PCM. Thorough inspections of associated circuits and components can lead to accurate diagnosis, thereby facilitating successful repairs. Staying ahead of potential issues through preventive maintenance can safeguard against future occurrences of this DTC. Overall, addressing the underlying problems effectively will enhance the vehicle's performance and reliability, ensuring a positive driving experience. Please like and subscribe to the channel. See you next time.